Yeah, I'm very happy to be the last speaker because that gives me maybe most impact for the discussions. And I will be talking on the dimensions of software documents. And all this was triggered at, first of all, I read the book on CMAT, and Eva visited us. And one of the questions I asked him couldn't answer. Why are documents so blatantly absent in CMAT? And why is there not more information in on that in CMAT, and why is there no part of the theory talking about all kinds of software documents? And when I talk about software documents, this basically means everything which you can put on a piece of paper, put on a whiteboard, everything from the first sketches to the final code. So this is what I will be talking about, but before that, actually I do a minor excursion which is actually belonging to the slot yesterday, which is still my 2 pence on what is a theory. And since we had some discussion with some people on that, I even added a slide on that, which is a theory which comes from communication psychology. And I didn't hold psychologists in very high esteem, I must admit, until I came across this theory, which is just basically putting the right words on things. And it's so obvious what happens then. And this is something which I just would like to give to us to show maybe we can do something similar. And I have the feeling that CMAT is exactly that putting the right words on things. So that's what I think is nice. So and then I have my perspective to actually what would be software engineering theories. What I would like to have for. That doesn't need to be your picture, but I just wanted to sort it out for myself. And maybe we can discuss it. So this is now a theory from communication psychology. Simple situation, some guy sitting in a car next to a lady says, "It's green down there." The point is, many couples will start already about quarreling about this sentence. The reason is that actually it can be taken in many different ways. The red one, the traffic light is green, this is a fact. This is one side of a message. Then the other is, drive faster, so that we don't miss a screen face, so that we don't need to stop at the traffic light. That's a request, do something. Down there, I'm in the position to tell you how to drive. Maybe husband and a wife, I don't know, but this is, would be something, I'm in the position to tell you something. This is about the relation of these two people. And bottom right, I'm a good driver, this is about myself. Oh, I know how to drive. And all this can be put into the single statement, which might be a fact, might not, we don't know. And I would bet, after I knew about this theory, I can explain many communication problems. I would say almost 90% of them, when I see them, there's some problem in communication coming. It has to do with this. And what this psychologist, Schulz von Thun, Hamburg University, did is he put, basically said, okay, we have 4 ears and 4 mouths, and we need to be bit careful. When are we talking about what? Do we talk about facts? Do we talk about self-disclosure? Oh, me is somebody who's really great doing something, or the relationship, I can tell you something, or is it a request? And this is something which I think is so simple that even from just the words he put on it, you can derive things. He of course has a lot of theory how to do pair therapy out of this and all kinds of stuff. But just putting these simple concepts in there, when we talk facts, it's not facts, but very often it's 3 of the other things. And actually it's very typical, I would say, ladies typically state a fact, our men would take them as fact, but actually it's a request. The wastebasket is full, bring it down, but she doesn't say it. Men are even worse, they think they are talking about facts, but actually for them it's self-disclosure. I know something. And this is where communication goes terribly wrong. And I would claim this is a really nice theory of communication because it helps me understanding what's going on. We could discuss some details offline over lunch or so. I really like the theory. What I learned from it is just putting the right words of things can help. Of course, what's also important is really good examples for that, which explain, yes, there are these 4 sides of a message as Schulz von Thun calls them. Okay, I'm not going to that anymore. Now I would like to talk about software engineering theories, and I would put that in quotes because sometimes I'm not sure whether that's theories. Actually, in some papers here, in particular the ones referring to other papers, I very often saw some things which was basically, this is fact about software engineering, like object orientation is better than structured programming. This is just facts and observations for me. This is not theory. There are some experiences, there might be even some empirical studies and some facts which sometimes are called laws. I wouldn't call them laws, but I'll come back to that in a second. Then there's something which also very often is called theory, which is what I would call methodology in general, or maybe in this context very often we call it practices. So this is maybe choose some principles. How do we do things? There might be some notations how to do things. There might be some process described, and so on and so forth. Waterfall model, agile, or also something like object-oriented analysis and design. All this stuff I would put there. And in the best case, we can, from these facts which we made here, we'd say, okay, this was developed and we maybe based on some observations, and we have some rationals for that. And we could even relate to others. This would be already nice. But I wouldn't call this and the theory. What I call theory would be something up here, and I added the word general because this is the name of this workshop. So general theory would actually, from these facts, try to derive some terminology, ontology, whatever, maybe some important parameters, make some laws, so that basically these laws reflect what we observe, and of course we would like to explain also from, now we have the theory, explain why we have these facts over there. So that would be a job of a good theory, relating these two things, coming from here to the right terminology and the right laws. More importantly, would be that we go down here from this general theory and say, now we justify why we have this methodology, or we can use the terminology, and that's what I guess is SEMAT is about, and what I like about SEMAT is it introduces the right terms, ontology, to describe methodologies. And what I'm really a bit angry about is when there's lots of theory, methodologies out there for how we should do things. And many of them I like, and many things I like in there. And then there are some things I don't like, and I know they would never work. And then I need to sort out when I'm teaching to my students, yeah, this general thing is nice, but this and this is not working. And I would like to have something where I have a set of principles in general, what is working, what's not working, so that I can talk about this up here. So this is where I would be heading for a theory, and this is why I would like to have a nice theory. And this is the background for actually the talk about the paper. So that is something which I think is important. Last thing which I would also like to point out is, I think it would be very important to separate between a theory of software and a theory of software engineering. Keep them apart as far as we can, or a theory of computation. Now my actual talk starts. And this is, actually I don't propose any theory, it's just an idea which I would like to put here to say, is it worthwhile pursuing? And this comes very much from my teaching experience, where I have a very hard time explaining my softwares when they do maybe a first product definition, or even writing a sentence, what is the objective of this product ultimately? They will right away come with functional requirements. They'll never talk about what should be achieved with this, formulating something on a higher level of abstraction. This is terribly hard for them. And this is some pictures which over the time I put to my lectures to tell them, when we talk about examples about models, is it more like these, where we can look at as an end user, or is it more something like technical? And in particular, when writing documents, my question now turns out to be, when they, for example, should write about in the early phases, is this about what the software should do, or is it about how the software should be implemented? So those two words now, I even find them in the document when they write them. In this section, we write about the how of the software, or in this section, we write about the what of the software. This is something which is very important for me to tell them, okay, don't talk about the implementation right now. This is about the how, it's not about what the software should do. And of course, there's different levels of details, rough or detailed. This is also something which I use all the time when something is going wrong in the documents. Think about, is this about what and how? And out of this, I said, okay, there's a space of documents which we need to write. I don't want to give a fixed table of contents. This is how to write them. This is again the problem. It's more about the principles behind than follow this stupid table of contents. And that's where I thought about, okay, what are the characteristics of the documents which we produce typically? And there's one dimension, I don't even have a nice name yet, which I call the what-how dimension. And we typically start down here on this lower left corner. We start with something which is objective. This is what what the software should do or what should be achieved by it. And ultimately we talk about how it is implemented. Of course, we are going from a very rough idea. This would be the project objective. And ultimately, of course, we have it on a very detailed level. Could be called level of abstraction, but I'll come back to that later on why I don't do that now. And then, of course, we have also things, first of all, we have very informal descriptions. Later on, they're going to be very formal. In particular, as I told you, code is also a document. So executable code is very formal. And also there can be formal specifications of the domain, or formal definitions of the domain, and formal definitions of requirements. And I believe that just giving an orientation where in the space are we when we working in the software engineering process, it tells very much about what the process is about. What we would of course like to achieve that somehow we come from here to up in the right corner. And maybe if so, at least if it's about implementation, we would like to end up here. Then the question is, over the course of the project, how do we move through this space? So that's basically the question. And I believe that actually the trajectories we can take through the space say very much about different kinds of process models. I have many questions about that which we could discuss later, but I jump over them right now. But we could come back to that in some questions. I also propose in the paper a scheme how we could discuss it, like the design patterns of the Gang of Four. What I think is important, having some kind of litmus test, say, okay, now if you need to write this document, is this document really, is this in this area, is it more about the what, or is it more about the how? So with the simple questions we could find out, is it a what document or is it a how document, for example. And of course, this is also something which I take from the Schulz from Thun example from communication psychology. We need to have good examples which characterize some dimensions where a document should be written in. Okay. So there's one dimension which I up to now didn't even give a name. This was rough, the rough detailed level. But actually this can be split up. One thing is more, for example, once you break down requirements, and don't even dare to say that word anymore, requirements, you would have kind of coverage how many of these requirements are covered, and typically you split them up, and some of them can be implemented individually independent of each other. In Agile, you would typically do that to describe a user story. We could discuss where that would be placed in this domain, and then you implement it, and then take the next, and the next, and the next. And that is what I would like to call coverage. And then, of course, there's also the level of detail on which this is described. So this is something which would probably would need to be discussed. And actually, there's also entanglement of some other dimensions which could be eventually discussed. So I'm not even saying these are the 3 dimensions. I just say maybe that's the one which where I would start from, but there might be some others. So, for example, level of detail, that is something we discussed already. Declarative and executable is related to probably informal and formal. Textual graphic, I even put that in gray because I don't want to start that debate, what's better, graphics, non-graphics. That depends on what you do. One thing which is very important, I guess, is level of precision. Imprecise, I put that in quotes because I think that's not an English word, but also the loose has many different meanings in the formal methods world, so I'm not quite sure what to use there, but I guess you get a feeling. So we would like to have imprecise descriptions and more precise ones. All of them we need. Okay. So let's come back to this goal. This is actually the question, would that be the goal? Or should it rather look like this? This would be probably the waterfall model. This would be a hot project which I can do in a week or so. I don't need anything down here. Somebody tells me, maybe have a small dot down here, but then I just implement it. Or in Agile, it would rather look like this, where we have a user story, a test, which is formal and detailed, but it's not yet the how, it's just the what. And then eventually we have the formal thing, which is formal and the code, which is the implementation, so that's in the upper right corner. Only that we would iterate over and over again on this other dimension of this detail, so we get more coverage over time. And actually what the interesting stuff, and I guess I need to stop in a minute or so, the interesting stuff would be, for example, what would be laws about that? And my feeling is from the software engineering projects I did, and in particular from also the courses I do practical with the students where we develop something, these blobs here, they shouldn't be too far from each other. So I need to put my breadcrumbs out so that the distance is not too far. The waterfall model might in some cases be the right thing. Very often it's not. The agile might be the right thing. I can have these big jumps because this cube is quite small, and then I get the coverage over time. And that would be a law which I would expect is there somehow. I can't quantify that right now. It's just a feeling it would be worthwhile looking into that. And that would help on this level discuss progress models. When are they good? And I guess that talking about the distances of these hops, we could really easily find, yeah, this would work, this wouldn't work. And we might find a constant or some formula eventually even in mathematics. Right now I'm not interested in this mathematics, just giving a feeling, yes, there could be something. Okay, at that point I would stop. You have some questions in case you want to ask them. And what would be also important, the next slide would be, let's discuss some examples, where are they in this space? But I'll go back to the questions. Thank you very much.
Thank you very much. Only clarifying questions then. And you have one.
I hope so. If you go back to the previous slide,
yes.
We see the cube.
Yes.
I'm not sure that the cube is a good choice to describe your presentation, because I'm certainly willing to agree that detailed and how have something in common, but I would never say that what is rough. What may be very precise.
So actually this is the very purpose of this is that these are independent dimensions. So you can be on the what level and it could be rough, and you can be on the what level what is and be detailed.
But you are describing trajectories.
Yes, but these are the red paths.
Assuming that this is a point.
Yeah.
So I am not sure this is a point.
Yeah, so actually this has volume. That would be also interesting to discuss, but I guess this is not clarifying anymore.
I think that we're moving from clarifying to a general discussion now.